Another exponential example here given in the notes. So from what point does a woman decide, from the time she decides she wants to be with the guy she's dating, that she would like to marry him, what length of time in between there will she wait for a proposal? Okay, so this is what I would lovingly call the crap or get off the pot kind of question. Okay, so let's say this can be modeled with an exponential distribution where the woman will wait half a year between the time in her mind that she decides this guy's marrying quality, that she'll wait half a year from that point for the actual proposal. Then she'll either propose herself or she'll just, say it's time to move on. Okay, so here then beta would be 0.5. So what's the probability that she'll wait between 4 and 7 months? Okay, so let's find this out. Originally we have beta. Okay, so here it says years per event. She'll wait 0.5 years per proposal. Okay, I know that's beta because I've got time given a count. Okay, so that's got to be beta. It's also told to me to be beta. Okay, so here if I want to rearrange that out of years and put it into months, there are 12 months in a year. I can just multiply this 0.5 by 12 and I'll get months per event. Okay, so if you're saying she would wait half a year, you probably could see why that would be listed as 6 months is half a year. Okay, so 6 months per event. I've just reparameterized beta here. Let's use a random variable. Let x be the amount of time she'll wait until the proposal. In this case, I'm reminding myself that beta is in months. Then I can say x is exponentially distributed, where beta is 6 months per event. So what's the probability that she waits in between 4 and 7 months? You can do this by hand, or of course you can use Minitab to do this. Okay, 7 and 4 months are the particular points of interest that I'm considering. Probability distribution, this is the exponential. Okay, what is the cumulative area here? I'm expecting she'll wait 6 months. So in between 4 and 6 months, oops, let me redo that. Didn't do the right thing. Here I need to say the column where I want my answers here is in between 4 and 7, so I want this to be column 4. Okay, let's just put the answers into the sessions window. Here, the cumulative probability of waiting at least 7 months. Here's the probability of waiting at least 4 months. If I subtract these two, I will find the probability of her waiting in between 4 and 7 months, about 20%. Okay, with probability 0.5 or 50%, she will wait at most how long? Okay, at most is the less than or equal to sign. What I'm saying here is if I draw this picture out, 50% of the time a girl will wait how long? That's what I'm wondering, okay? So 50% of the girls will wait how long before they leave. Okay, again, you could use logarithms to solve this. It's easier to use Minitab to do it though. This will be probability distribution exponential. Here I have the inverse. I've got the area known and I want the value here. Okay, so that's inverse. On average, a girl apparently waits 6 months. Here I'm saying, 50% of girls will wait how long? Okay, so it says 50% of girls will wait 4.16 months. Okay, so about 4 months. Okay, so 50% of girls will wait, at least 4 months. The other 50% won't. Okay, here, if she waits at least 6 months, then what's the probability she will wait a total of 9 months? Okay, so here we've got we don't have like A where we've got an and statement before, between 4 and 7. Here we've actually got a condition. Let's say she's waited 6 months. If we know that she's already waited 6 months, then what's the probability that she will wait a total of 9 months? What the exponential distribution says is that it's memoryless. We've seen that earlier, which means that just because of the fact that she's waited 6 months already does not mean any amount of time is going to change from there on in. Really what the memoryless property says is we can just say the probability of waiting total of 9 months given she's already waited 6, it's the same thing as the probability that she'll wait more than 3 months. Okay, so this question just simplifies because I've got a conditional statement and I can use the memoryless property. I can say this is just the same thing, waiting 9 months given she's already waited 6 is just the same thing, oops, that's not what I want. It's just the same thing as her waiting more than 3 months. Okay, so here's the probability that she waits less than 3 months. You can see here it's the less than sign. If I really want the probability that she does more than 3 months, I do 1 minus this answer, and I will get the probability that she will wait a total of 9 months given she's already waited 6.